Hello everyone. Today we are going to look at IGCSE topical questions because yesterday I have given a video. I mean not video. Actually I have given a post that today we will have a topical session, and here we are. But I didn't mention any time over there. So today we are going to look at some topical questions I have chosen. So though I'll show those questions so that you will be able to understand how the topical questions are answered, or how the questions are answered in past papers. Alright. So this topical is from 2025, and every sessions are included: February, March, May, June, and October, November. So today we are going to look at those questions which are related to conversions, which are related to 2s complement, which are related to binary, denary, hexadecimal conversions, which are related to data storage, and many more. Alright, let's move on to the questions which we are going to do now. Over here you can see that I have also included many things. Alright. As you can see that, okay, so the first question is about the Denary numbers 19 and 230 are converted to binary, and so we have to store it in the RAM. So now we have to convert two Denary numbers to binary numbers. So I will only do one of them so that you will be able to understand what I am doing over here. So as you can see that I have taken I will do 230. So how do we do the 230? So first of all, 128, 64, 32, 16, 8, 4, 2, 1. So over here we are going to subtract 230 from 128. So let's subtract. Although we are not allowed to use calculator in computer science paper 1, so we will just for now I'm using the calculator so that it would not consume too much time. 230 minus 128, over here it comes as 102. So we put 1 because the 230 is greater than the 128, so that's why we are gonna put 1 over here. If it is less than the 238, then we will have to put 0. Then 102 is then divided by subtracted by 64. So over here we have 38. Then 38 is going to be subtracted from 32. 38 subtracted from 32, so it comes as 6. And then as 6 is not subtracted from 16, so that's why you're going to put 0. Then this one will be also 0. And then over here 6 is subtracted from 4, so it's 2, so 0. And 2 subtracted from 2 means 0, but we will put 1 over here because it's subtracting. And then 0 is not subtracted with 1, so it will be 0. So this is the binary value: 1 1 1 0 0 0 1 0. So this is the binary value. Let's move on to the next question, which is about the two hexadecimal numbers to binary. So I'm going to do only one of them. It is one this value, which is 8AD. So how do we do that? 8A and D. Firstly, we are going to give a line over here. Okay, so we have 8 4 2 1. So how do we do it? If you look at the last videos which I have posted, the lecture videos, So you will be able to understand those. If you are able to understand those, you will be able to understand the topical past papers which I am doing right now. Alright, so 8 is subtracted from 8, so it's 0, I mean 1. First we are going to put 1 and then 0. So 4 is not subtracted with 0, 2 is not subtracted with 0, and 1 is also not subtracted from 0, so 1, 0, 0, 0. Alright, A means 30. I mean A means 10. How? Because if we have learned that A equals to 10, B equals to 11, C equals to 12, D equals to 13, E equals to 14, and F equals to 15. So if you have learned those, then you will be able to understand this one too. So D is basically 13, so we are going to put 13 over here. A is 10, so 8, 4, 2, 1. So 10 is subtracted from 2, so I will put 1 over here. Then is subtracted from 2, then 2 is not subtracted from 4, then and 2 is subtracted from 2, so it's 1 and then 0. Right, so this value is done. 8, 4, 2, 1. 13 is subtracted from 8, so 13 is subtracted from 8 comes as 5. So 5 is subtracted from 4, so it's 1, so 1 and 0 and 1. Alright, so let's move on to the next one, which is okay, so the value is basically 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. So this is the value of binary after I have converted from the hexadecimal to binary. Let's move on to the next question, which is about, I have selected this question so that it will be easier for us to do as many as we can. Let's move on to the next question. Alright, here we are with the next question, which is the binary addition. So how will we add it? We have understood that how we will going to be adding it. Okay, so over here we have actually have to memorize 5 rules as a golden rules, as I have told before. Those rules will help you a lot to master this question too, either way. So 1 plus 0 is 1, obviously. 0 plus 0 is 0. 0 plus 1 is 1. So like we do the normal addition. 0 plus 0 is 0. 0 plus 1 is 1. And 1 plus 1 is 0 and carry 1. And 1 plus 1 plus 1 is 1 and then carry 1, 1. So this is the value you must remember that in golden rules we have 5 rules, that 1 plus 1 will be 1 and then we will have to carry 1 against. Next we have, in the other case, if you see that if it's 1 plus 1, 2 on ones, then it will be 0, then carry 1. If it's 1 plus 1 plus 1, then you must also give 0, but we are not giving 0, we are going to give 1. So then we have to carry 1, because these two rules are different, because one says when there is 2 values of 1, that time we will have to put 0, then we will have to put 1. Other hand, there is 3 1s, so that's why we have to put 1 and then another 1, so that it will be easier for it. Next we have about the overflow. It's a very important question, like how overflow error occurs. Like it is said that an overflow error occurs when other 8-bit binary numbers are added together. Explain why the overflow error occurs. So we know that when a number is larger than, or when the number is greater than a register can store, like 8-bit register can store, it is generated an overflow error occurs. So that's the answer, but still we have to have 2 marks answers. So another one will be why? Because as the number is larger than 225 in an 8-bit register, So now let me write it, then you will be able to understand. Like, when a number is greater than a register can store overflow errors occurs. Overflow error occurs. Okay, why it occurs? Let's answer it. Because the value is larger than the 255 in 8-bit binary. I mean, my bad. 8-bit register. 8-bit register, which causes the carry one value to be lost. So this is the answer you must write, and this is a perfect answer for 2 marks answer, because they have given enough space to mention everything in a single row. So let's move on to the. You must take a mark scheme and you will be able to find out how the answers are written. Like, they are giving only points over there in the mark scheme, and in the other side they will give you A1, C1, B1, whatever it is. You must read those in the mark scheme section. It is written over there, like what are those A1, B1, C1 means actually, M1, all the things are mentioned over there. Next we have negative Denary number 222 minus 22. So how do we know like negative? So the negative number must be in positive. First of all, like in negative number, what we must do is that we must make it positive. So it's 22. So 128 64, because already told that 8-bit binary, so we will put 128 64 32 16 8 4 2 1. So like that way. 32 16 8 4 2 1. So over here what we have to do is just do the thing like subtraction. 0 0 0, then 16 22 minus 16. 22 minus 16 comes as 22 minus 16 comes as 6, and then 0, then 4 6 minus 4, which comes as 2, then 2 minus 2 comes as 0, so we put 0. Alright, so now we have to do is what? We have to swap the value. So our rule is to swap the value. So we will do what? We will just swap the value. So let me write here swap value. Alright. So 1 1 1 1 0 1 0 0 1. So then we must add 1, because we know that we must add 1. Okay, so we will add 1. After adding 1, we can see that 1 plus 1 0, and then carry on. So 1 plus 1 0, we will put 1 here, so we are carrying 1, so 1 is we put over here. Then 0 1 0 1 1 0, I mean 1. So this is the value which we have done. Like totally we can see that we can have done it to binary, and then we have done to its complement. So it is a very much like what I would say, like a good question. I would say a good special question, obviously. So 1 1 1 0 1 0 1 0, this is the number. Let's move on to the next question, which we have over here. So now it has said the size of the image is 3072 bytes, and now it has told us to do kilobytes. So in kilobytes, like we have two types of conversions over there. One is kilobytes and one is kilobytes. So there was in A-levels we have two discussion, like compare kilobyte and kilobytes. But right now we will have to stay stuck in one position. Like we have to convert this thing to kilobytes. So how do we could do that? Like 1 byte is 1024 bits. So 1 byte is 1024 bits. 1024 kilobytes. My bad, 1024 kilobytes. So 3072 bytes is equal to 3072 multiplied by 1024 kilobytes. So as we are converting to kilobytes, so that means what will we have is 3072 multiplied by 1024, which means we will have 3145 5 kilobytes. When we will get the bigger value, then just estimate it and do some significant figures and then find out the thing. As I'm using the calculator, so that's why we ain't, if you aren't gonna be understanding these values, like just multiply it, then you will be able to understand it more easier way. So now we have 1 byte and 4 nibbles. So 1 byte means 4 nibbles, so we will put 4 nibbles over here, nibbles. And then next we have image file has a color depth of 32 bits. Now what is mean by 32 bits? So we know that color depth means a number of bits used to represent each color. So we will just, instead of the number of bits, we'll write a 32 bits used to represent 32 color is called color depth. So color depth means depth means 32 bits represent each 32 color is color depth. Okay, so over here they has told us color depth of the image file is changed to 64 bits. They told us that the color depth is changed to 64 bits. So what effect this has on the image? So what effect does it have on the image? So like what kind of effect does it have in the image? So what they are trying to say. So what effect does happens in the image? So we could say, wait for a moment. Wait for a moment. Let me check the masking. What does they are trying to say over here? Okay. So in the masking, what are they trying to? What they're trying to discuss is about, like, when we are actually like color depth is when the color depth is changed to 64 bit, that means they will have more colors. We will have more colors, which means the file size will be more increased. So what will be right here? So they have told us to what is the effect. So what is the effect these changes has on the file image file? The file size will be increased. We must write that first, that the file size will be increased. The file image file size will be increased. Meaning more bits are used per pixel and more colors will be added in 64 bits. Make the image more colorful. Alright, so this is, you can tell 2 marks in this question, not more than this. Let's move on to the next question, which I told about that image file is compressed using lossless compression. So how we uses lossless compression? So we know that that lossless compression means reducing the file size instead of deleting the whole data, right? Deleting the whole actual data or permanently removing any data. Permanently removing without permanently removing any data. Alright. So compression, lossless compression uses compression algorithm to reduce the file size, instead of deleting or permanently removing any data by the process of RLE, because it has by the process of run length encoding the image file will be grouped together repeating the patterns, and indexes done. So you must write this much answer to gain 3 marks. Let's move on to the next question. Okay, so they have told us to do binary to denary. It's an easy thing. Just what you have to do, use 128, 64, 32, 16, 8, 4, 2, 1. So over here what we have to do is I'm just going to do this math. Probably 1 0 1 1 0 1 0 0. So over here what we have to do is just add them together to get the value. 128 plus 32 plus 16 plus 4, so which comes as 180. So 180 is the denary. 180. Alright. Let's move on to the next question, which is logical shift. So this is the value. So what we have to do is logical shift 2 places to the right. So 2 places to the right shift, right? They've told us right shift. So how did the right shift? Anyone have an idea? Alright, let's do it. One 0 1 0 1 0 0. So over here we will do the right shift of 2 places. So we will just take this. So right shift RF right shift. So we will just put 0 0, then 1 0, then 1 0, then 1 0, then 0, and then 1. So this is the right shift. So 0 0 1 0 1 0 0 1. So this is the right shift. Then we have to do is so this is the thing we have done. Now let's move on to the next one, which tells about this is the measurement of the height of the amplitude and taken time intervals. So it's called sound sampling. Sound sampling. Next we have over here the sample rate. So what is sample rate? Sample rate is the number of samples taken per second. It's called sample rate. Sample rate is what? The number of samples taken per second is called sample rate. Then sample resolution is the what? The number of samples the number of bits per sample is called sample resolution. The number of bits per sample is called sample resolution. Let's move on to the next one, which is told about the smallest unit of storage is the byte is the not byte, its nibble is the smallest storage. Alright, so how many terabytes are equal to 2 PB? Very important question. How many TB bytes are equal to 2 PB bytes? So we know that 1 PB byte means 1024 terabyte. Which means 2 PB byte means 2 multiplied by 1024. So what we get? PB bytes. So 2 into 1024, which means 2048 TB bytes. Alright, let's move on to the next one, which is it tells us about the size of the file need to be reduced. Alright, so the name of the process, what is the name of the process? The name of the process is lossy compression. So lossy compression. Name of the process is lossy compression. Another one which is told us about, give one reason why the size of the file may be reducing. One reason for this file is going to be reduced so that the short transmission time. Give one reason, other reason why the file size needs to be reducing, because what? Less storage is required. So less time taken for the transfer. Any of them. Less storage will be required. Okay, so less storage will be required. So let's move on to the next question, which is about the last. Today I am going to do the last question only. I think this much is enough, rather than easy. Typically, very much easy. Let's move on to the last question and the final question. Let's see. Okay, so this is a very much good question. Today for now I am going to do only this much questions, and the second topical video I am going to show the other tools. Alright, so over here they have told us to tell what reason why the hexadecimal value needs to be the value displayed instead of binary. Because why? Because the hexadecimal is easier to read and write, obviously, and hexadecimal takes less space. Okay, hexadecimal is shorter and it takes less space, whereas takes longer space. So hexadecimal is easier to read and write hexadecimal takes shorter hexadecimal takes less space, my bad. Takes less space. Alright, so there are some more questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are about 10 questions left, so in the next video we are going to solve those. For now we are going to keep up from this way, and in the next Friday we are going to start the new lecture, and then I will post the last video for the topicals. And hope you like this video. Please hit the like button, and please, if you want to subscribe, please subscribe, because if the channel becomes popular, then I would be happy to do some more. I will not be happy, I will be more interested, or like, what is it, like anything. Anyway, so take care, and see you in the next video of data transmission.